Well, good morning, everybody. This wind field that you're watching here to get us started on Monday morning is going to be a critical setup for the remainder of this week. And what I'm talking about is be careful with just what you consume on social media or from kind of untrusted meteorological resources, because there is going to be something significant happening in this area in terms of a storm system. Large Arctic high is pushing down. It's going to be pushing against a high pressure cell that's going to move off the southeast coast, and there's going to be this deformation zone, this convergence zone here much later in the week. We're going to talk about it. It's been something that we've been thinking about now, right? For about 10 days. We knew that the setup for this January, 22nd, 23rd, 24th, 25th, I don't know, that whole time period was going to unleash some pretty nasty Arctic air. Now, these are the winds today, though, all right? So I'm trying to show you the setup. And there's an interesting observation that we've made many times over the years on this channel. When you have big fronts that clear all the way through the Gulf here, get off the East Coast, okay, there it is. Sometimes this sets up what we call the Tejano wind. So there's a pass through here where there's a major shift in elevation. There's this kind of funneling effect of the flow, which just rips winds through this area. And they're quite strong. There's a couple places this happens in Central America as well. What's neat about this is what it does to the ocean. So what's nice about this website, if you've never been to it, earth.nullschool.net, I show it every single video I think I produce. You can come over here and switch this over to ocean. I'm going to put it back on the wind so you can see it. But instead of showing the currents, I'd like to show sea surface temperature anomalies. What's interesting about this is as this wind comes ripping through here, okay, you're going to blow the surface air in this direction. And what that does to the ocean is allow for upwelling. That's colder water to replace the surface water you've kind of seen move in this direction. And it's interesting, that artifact, that whole idea of getting water to upwell from below due to winds is ultimately the driving factor between, well, El Nino and La Nina. If we zoom this out, I mean, for 5 out of the last 6 years, we've had stronger trade winds that do this. They kind of come in this direction. They move across the open Pacific Ocean. And the cooler water that you see here is emerging from below as the stronger winds push the warmer water over to what's called the West Pacific Warm Pool, which is all of this over here. Now, we have been detailing in every video for a while now that this whole process is about to end, this whole idea of these stronger trade winds, and this warm water is going to come sloshing back. That is the end of La Nina and the beginning of an El Nino event, which we think could be a significant one by the time we get into summer of this year. But that's not the story today. The story today is if we just come back to this, let's just do now and let's go back to the atmosphere, all right? So this is early this morning on Monday. In winter, whenever I see this, it's telling me that the thermal contrast across North America, in other words, where the greatest temperature gradient is, it's not here, it's not farther north, it's going to come way down to the south. And essentially, whenever you're trying to figure out where the storm track is going to be, just find that thermal contrast. And if it's north, you're going to get storm tracks to the north. In fact, what have we seen throughout so much of this winter? It's been very mild here, right? So we've had mild air there. So the thermal contrast has been along the edge. We've had clippers, in fact, there was one last night that came through the Great Lakes producing strong winds. Now, if you take that thermal contrast and flatten it out, especially east of the Rockies, and push it south, well, your storm systems are going to live along that, and they're going to move in those directions. And that's what we're anticipating later on this week. Okay, so that is the setup for what we're about to get into, and here's the end result. What I'm going to play for you here is using the European model. We're going to watch through the end of this week into the weekend what could be taking shape in terms of a snowfall event. Now, it's pretty far out there in the forecast. Until then, it's a whole lot of this. A lot of cold air coming over the Great Lakes. And these lake effect snow events all week long are going to be huge. I mean, we're looking at another 6 to 12 plus inches, no problem at all. But I'm going to start on Friday and work you through, again, that time period, the 23rd, 24th, 25th, right there. So that is next weekend. And you're watching the animation of the probability, again, starting Friday and going through Sunday, of getting 3 more inches of snow. Now, just remember, when I show you probabilities, we're taking the 51-member ensemble forecast of the European model, all of its forecasts, and showing you how many of them, in a percentage, okay, are producing at least 3 inches of snow. So 50 to almost 80% of them are producing a 3-inch snow here, and it kind of extends over to the mid-Atlantic. And in some cases, some individual model runs are putting down monstrous amounts of snow. And we need to talk about it. But I need you to understand something. This is this weekend, this upcoming weekend. Where this snow is going to be, All right, the main axis of snow is going to shift north. It's going to shift south. It's going to contract. It's going to change in each individual model run. And that's where we just want to be careful consumers of weather information. You have to know we have a lot of uncertainty around this. The beauty of modern weather forecasting is that I can tell you now, in fact, we talked about this last week, that there's going to be something taking shape during that time frame because we watched these events unfold half a world away in the Arctic, and they were coming together to give us something here, shoving that temperature gradient into a new position. Now, we've already seen some snow. This is the last 72 hours of snowfall ending last night at 6 p.m. And there's been some good snows in the Northeast. These were well forecast. The snows around the Great Lakes here from these clippers coming through. And then this. But this was an interesting snowfall event. As you remember last week, remember all the hype around, there's going to be feet of snow in this area. We're going to shut everything down. And, it didn't manifest itself in that way. But there was some snow that came out of the Florida Panhandle. You probably saw some pictures of that on the internet in the southeastern parts of Alabama and then through the heart of Georgia here. But it was interesting. I went and just tried to watch to see as the clouds exited east. See, that was last night. Just trying to see if any of that snow survived. And the short answer is no, it didn't. It melted very, very quickly on the backside there, so we don't even see the snow swath in this area. As soon as the sun came out behind these clouds, boom, it was gone. And that's very typical of the South, right? I did notice a couple other things. So we do see quite a bit of controlled burns going on here in Arkansas, parts of Louisiana. In fact, pretty large area of smoke coming out of this section of Louisiana, and some of these in Alabama too. I went looking, I'm like, well, maybe one of our high resolution satellites caught it, and they didn't even either. So, and this melted very, very quickly in this area. And by the way, I wanted to see those burns. Yeah, down there in parts of southeast Texas and just well north of Lake Charles, but into this area, we can see some of the smoke from those fires. Another neat thing to take a look at here is this was yesterday's satellite data just as the sun was setting. And while we are grabbing daylight hours, I mean, they're coming back, boy, the tilt on that is poor, right? That's why the northern hemisphere has got such little sunlight in terms of its directness and duration during this time of year. But have a look at the Pacific Northwest. Just look at the depth of this, this Columbia Basin, fog getting into the Snake River Valley as well. In fact, even more in the San Joaquin Valley down here in California. These are these air stagnation issues we've talked quite a bit about. I just thought you might want to see some satellite data early this morning. All right, but this is the setup. Okay, there's the air stagnation issues here and the fog. We do have a winter weather advisory here in Montana, but around the Great Lakes is where most of the action is going to be. These counties outlined in white represent where we have got cold weather advisories. So it's very, very Arctic air. And this is going to change a lot in the coming days. We're going to see more extreme cold watches and warnings, all of that coming out, especially as we approach this weekend with this Arctic air that's coming through. Once again, it's a very cold morning down into parts of Florida where the temperatures have been bottoming out near freezing and below. And this is uncommon for this to happen in Florida, but it does. It's not. I shouldn't say it's rare, but about this time every year we start to watch for something like this to take shape in parts of Florida. Now, if you want snow in the near term, you're going to have to go to the Great Lakes. That's going to be the best shot at it. And the Great Lakes right now are 18% covered in ice, so there's still a lot of open water, and which we could use to make lake effect snow if the upper atmosphere temperature. Let me rephrase that: if the lower atmosphere temperatures are cold enough. I did find a new resource for this I really like. This is the Great Lakes Ice Tracker, and it's using the same data as what I showed you here, which is from the US Ice Center .gov. But what's nice about it is it shows, the historical past up to this point. So I liked being able to see all of that data, knowing we're at about 18% now and where it stacks up to previous years and then, years back, 40, almost 50 years ago. So just another unique resource is it's GLICE. So it looks like glice, but it's Great Lakes GLICE tracker.github.io. Just a great website here to have a look at. Okay, back to this temperature. What you're going to see all week long are waves of Arctic air, like the ones we've just seen coming in from this direction. So this is this morning's temperatures as compared to yesterday morning. So it's the difference in 24 hours. But the story is going to be the temperature in the Arctic. And this is what we covered last week, but look what's happening now. So we've been concerning ourselves with the way that this ridge between Alaska, the Bering Sea, getting up the Arctic, is going to kind of bridge with a ridge coming off of Scandinavia. And as I play it through, It's what happens to the cold air that's typically there that we have to pay attention to. Because by the time we get into Thursday, Friday, and then this weekend watch, this weekend, I'm watching these two blue lines. This one and this one. We talked about last week, the 540 line, because they create a complete closed contour here. Look at that. So that is how much warm air has been pushed. And all the cold air is just going to come racing out toward the south. And it will be aligned with a stratospheric event where the polar vortex sits here. So all of this getting pushed in these areas, okay, is allowing cold air to come through here, and it's going to be sitting on top of the the low-level trough. We're going to have a stratospheric polar vortex displacement event right there. So what I'm telling you is, this is when the atmosphere gives us its best possible shot to deliver cold air to the eastern half of North America. And I got to ask a good question. Why doesn't the polar vortex ever sit over the Northwest? Well, it can, but normally where we have our biggest disruptions in terms of squeezing in high pressure and warmer conditions is it where these two spots in the North Pacific and North Atlantic allow warm water to get here, right? Everywhere else around the Northern Hemisphere, we don't have water at these latitudes. We've got land, we've got Russia, we've got Europe, we've got North America. But that's why it typically sends the polar vortex in this direction. Okay, I thought that was kind of a neat question I got in the questions last week, and I wanted to point that out. So let's have a look at the European model and just kind of use it as our benchmark to get things going today. We have one system that exited last night into the northeast. A little clipper comes over the Great Lakes. There might be some snow that sneaks through Colorado later today, but most of the snow is going to be on the Great Lakes. I've got another clipper coming through Montana, parts of South and North Dakota, into Minnesota, Iowa, Wisconsin, Northern Illinois by the time we get into Tuesday night into Wednesday morning. This is the wave we mentioned last week coming out of Texas, possibly bringing in some showers right along some wetter weather here along the Gulf Coast. But north of that, there's plenty of cold air to support more snow showers and more snow squalls. If you haven't experienced one of those in this corridor yet, you've got more chances coming. This is Thursday, and as one high pressure cell pushes this snow toward the north and east, we're going to add a bit more there. We'll look at the totals in a second. But the real show begins on Thursday. Thursday into Friday, this high pressure cell starts to push its way farther and farther to the south, and it's a big one. And the surface wind, cold and dense, is going to undercut warmer, more humid air coming up out of the south. And we're going to layer the atmosphere with different temperatures right there. So what ends up happening is there's no deep low with this. Know what I'm saying? Like you don't see closed contours of low pressure. But what you get is this squeeze and this layering effect. And so that by Saturday into Sunday, what do we see? Rain to the south, icing event possible here, and then heavy snows to the north. Now, what is determining where this is all taking shape is this high pressure. And that will move in each new forecast. So do not be surprised at all if you see this snow swath moving north. Same thing with the ice and rain. Or it could move south. It's going to move. I can just promise you that it will move. But going forward, this is now Saturday morning, Saturday afternoon, Saturday evening. You can see this event could possibly produce quite a bit of ice. Now, can I show you something kind of neat about this? I don't have this functionality built into my website, but my friend Levi Cowan does on his site, Tropical Tidbits. I think many of you know about this site. So this is the same data, the European model. We're looking at the same thing, and here it is. This is now out there early in the morning on Saturday. Now, can I show you something neat? The functionality I want to talk about is the ability to click and generate a forecast sounding. So it's the temperature and dew point temperature lines. Here you can see them separated going up in the atmosphere. Now, what we want to look at is the zero line, just to do something very simple today. If the air temperature and dew point temperature line are touching, the atmosphere is saturated, and they are. And then if you are on this side of that zero line, that means as you go up, never once does the temperature get above freezing. And that is why when you click right there, you see snow. All right, now let's close that. And let's get down here. I don't know. Let's pick right here where Texas, the Arklatex region, Arkansas, Louisiana, Texas. What you have here, okay, is they're saturated, but the zero line runs right there. And so what happens is if you have snow that's falling here, six-sided crystals, they get into this warm air, and sometimes they completely melt or partially melt. If they partially melt, and then you fall back into the surface subfreezing layer, you get sleet, which is ice pellets. If they completely melt and fall back into this, you often get what's called freezing rain. In other words, it's still liquid, it's super cooled, freezes on contact with with a surface that is subfreezing. And then farther to the south, this, right? So there's your zero line. You have snowflakes falling, but then the entirety of the lower atmosphere is above freezing, so they just turn into raindrops. That is a terribly drawn raindrop. In fact, that's not what raindrops look like. They look like round spheres, or they look like hamburger buns. This is not a physically easy, a physically possible configuration of water in the free atmosphere. It doesn't make points, okay? Anyway, so I'm sorry. The whole idea is we're going to watch some sort of event take shape that could move from the southern plains through the mid-south and into the mid-Atlantic. And each new model run is going to have a different story. Low pressure really doesn't form until this thing gets off coast. But I want to show you what it might do, okay? So why don't we just get into some of the things I think everybody wants to see. Total snowfall. As we look at the European model, it's a lot of Great Lakes until the little clippers come through. They add a little bit more in through here, but you can see it's not much. So this is out Thursday, getting into Friday. Now here it is. This is Saturday, Sunday. And during that time frame, we've got this chance from the model for putting down 5, 6, 7 inches of snow. And then it gets really heavy as we approach over here to, Virginia. And that seems to be Virginia, maybe parts of Maryland, northern North Carolina, the potential for some of the heaviest snow. Now I'm going to take this, I'm going to flip it over to ice just to show you my concern about the freezing rain aspect of this. As we kind of zoom this back out a little bit, the risk on this ice, here it is, we're going to get out there a bit farther, there it is. Now, I often think that the models don't do a very good job at showing what the ice totals are going to be, but it's suggesting quite a bit. This could be a significant icing event, and I don't want to ignore it at all. Now, once again, I'm sorry to keep going over this like a broken record, but I think it's going to move. This whole area is going to move throughout the week. And again, your timing, Friday, Saturday, Sunday. That's the time frame over which we're attempting to watch this event take shape. Now, there's a whole lot more going on with this pattern than just this. Let's now look at some wind gust information, and we'll talk temperatures in a minute. As we play it out over the next 7 or 8 days, we are expecting more strong winds in the plains, through the Great Lakes into the Northeast, although thankfully the winds that are coming through the plains are not as crazy fast as they were last week, which were terrible in this area. But doing a quick analysis on that snow, let me show you some models. Let's go back to the old static map so I can compare it to the other models. I've got the European 7-day, so you just saw this. This is the European AI 7-day. They actually have pretty similar swaths, although you could say that the operational European model versus the AI is a little bit farther north. What about the GFS? GFS is farther to the south, but not as consistent on the snow band. It's got more of South Carolina and North Carolina and playing less of Virginia. And we'll watch. We'll watch to see who caves. That's the GFS, that's the Euro. These are the two primary models which we like to compare. We can also do it like this. Let's come back to the maps I started with. This is the probability of 3 inches through Sunday night. That's the European solution. That's the GFS. So the GFS is a drier model in terms of snow. But interestingly enough, the ensembles, so we run a 31-member GFS ensemble, is actually much closer to the European ensemble in terms of the placement. Now, all week long, please go to agweather.com and look at the snow. In fact, let's do this real quick. Let's pick a spot in Virginia here. Agweather.com. Go to my website here. And then let's go up to local. So let's go up here to local, and then let's type in, how about Roanoke? There it is, Roanoke, Virginia. I'm going to submit. I'm just curious. Now, Roanoke is a bit farther back, but I'm curious what they're looking at in terms of snow. Right now, the Europeans at 7 inches, 7.28. GFS, nothing. The blend of models is somewhere between 5 and 6. So you can kind of compare models and see how things look. The temperatures are going to be another story, though. Look at this cold air. Their European models dropping them down to minus 11 for a low on Monday morning. But you can see they're spread. That's just one way by which you can use the tools on this site. By the way, as we get closer, go to the National Weather Service 5-day and start reading what they're suggesting is going to be there on Friday, Saturday, Sunday. That's going to be an excellent application of this. Okay, what about beyond that? Sorry, we're getting on a long video here. We go back to this. I mean, have you not seen this all winter long? There it is. Troughs here, ridges in the west, and what that does is it makes things drier again. I was anticipating better moisture returning to the west as we got past this system into mid to late next week, but we're not seeing that showing up consistently in the model. The concern about all of this, if I just pick out the European model, is that how critical the moisture coming through this area is going to be, because that is the area that's been so dry as of late. Same thing with the east. Look at this. So we need to get this moisture in place. Now, again, this was through yesterday morning, so we did have some moisture get through this area last night, but we need to get some moisture back into this region. Temperature-wise, I mean, there it is. That is why you've had so many clippers that's just been going around that heat, but we're going to redistribute this, and that redistribution is complements of the Arctic. So I just picked a spot in the Boot Hill, Missouri, and I said, well, where's the air going to be coming from by the time we get to the 25th? And if you trace it back 10 days, it once was born up here in the Arctic and went through the Canadian archipelago, went over the Hudson, and then is coming through Canada. And that's your source region for this Arctic air that's coming into place. So max temperatures each day. Let's just look at max. Here's Monday, getting into Tuesday. Look at the warm-up coming out of the plains. Nice little warm-up here. Then you get into Wednesday towards Thursday, Friday. I think there's an issue going on with the National Digital Forecast Database, at least the reporting out of the panhandles here. But then you get into Saturday, Sunday, and there's some serious Arctic air coming in with this next system. I do want to show it to you just in terms of temperature anomalies. So watch this. The numbers here are shown in Fahrenheit compared to average. So that's through Monday, getting into Tuesday. So there's a warm-up that sneaks through, right in through there. Then we go past that. This is now Wednesday, Thursday. Now remember, the nose of the high pressure comes in on Thursday and Friday. Look at that. And there's your thermal contrast. And that's your storm track. But these temperatures are 35 to almost 40 degrees colder than normal. And they come snaking all the way down here into Texas. But there's going to be a very cold weekend setting up in this area with overnight lows throughout the Midwest, upper Midwest, northern plains well below zero. And then it pushes south and east with time. This is now getting out there to Sunday night, into Monday, Tuesday, another wave, and Wednesday. There's a lot of Arctic air setting up in this pattern. But things start to shift around by the 30th. And that cold air lingers in the southeast longest, and now we start to bring more mild air back. But the reality is, over the next 5 days, you're here. Day 5 through 10, that's the linkage between the polar vortex and the stratosphere and the tropospheric vortex. Very, very cold. It's only mild out west. And that's how we finish out the month of January. Cold east, warm west. Okay, what is all this? Well, we're going to start to dig a bit deeper into this. I told you that my favorite analogs for the remainder of winter are 18, 14, and 09. I just want to show you that this is what the January 18, 14, and 09 composites look like. Very similar to what we're seeing. So I'm starting to find these to be just better overall analogs. What about February following? We tended to go a bit more mild in the south, in the southeast, and we tended to see much more Arctic air living across the north. Interestingly enough, the new 1 month outlook put out by the Climate Prediction Center is very similar. See this? Mild, mild, very cold. So they're following some of this analog as well. I'm assuming they are. If we go beyond that, what about the February precipitation? Now, this would be interesting. We see that historically those years were quite active and wet here, and also wetter than average in the northwest. But drier California, so Sun Belt, part of the Cotton Belt, Winter Wheat Belt, and possibly over here in the southeast as well. I wanted to go out and look at some of the model data. This is the this is the European solution going through the month of February. It's trying to return above normal precipitation to a lot of the west and kind of keep things drier south of that line. Just model information. That's what we're looking at here. If we think through the transition and why the ECMWF looks that way, this phase 6 to phase 7, 8, 1, 2, we talked about this extensively last week. This, by the time we get to the end of this month, trades this large ridge that's living off the west coast. So in other words, this is now, that's big ridge here, deep trough there. Okay, that's what this means. It trades it for a trough that shows back up here. And that's why the European has the western U.S. going over wet and snowy and replaces what's now Arctic air with a big ridge in this area. So that's what the European model is up to. Okay. Could it be a possibility? Yeah, if the MJO does this transition, phase 2 is the transition from a big western trough that sweeps through the midsection of the country. All right. But what about my composites going beyond that? Might as well look at them. We're just going to let the composite of those 3 years live all the way through March, April, and May. And that particular setup was drier than average here. Now, this can be bad if it's extremely dry, but it can be fine if you're trying to get a crop planted and you need it to be less intense. So, by the way, the color coding, this is 3 inches below normal. Now, to be off 3 inches in March, April, and May, when you think about this part of Nebraska, which can pick up 7 to 10 plus inches on average, okay, we're a little drier than normal, but we're still getting moisture. Notice how wet it was in those years in parts of the southeast. From there, I do want to show you when you look at all of the years that transition. So remember, we picked these out about a couple weeks ago. All of the years that transition from La Nina to El Nino, we just tended to be drier here and drier in the northwest. So that's all of the years. I just showed you I showed you 2018, 2014, 2009. This is when I include the others. Now, what's interesting about this is how it might play out on a global stage. So can we do that to finish this up? Over the next 2 weeks, we're looking at very dry conditions into southern Brazil and parts of Argentina. Models are all kind of cluing in on this. Extremely wet through this corridor. We're trying to harvest a crop in this area. So this could be a bit of a hamper on things. But what I was curious about, though, is if I continued this thought process out and said, well, let's look March, April to May on those same years for global precipitation rate. And sure enough, it was drier in through here across the United States. But this is what's interesting. We're going to try to grow a safrinha crop. And if we are drier in southern Brazil, we do grow a bit of it down here. And so therefore, there could be some concern. Take a look at how dry Indonesia is in parts of Australia. In fact, even here, as we try to get a winter wheat crop to finish, we're looking at drier than normal conditions. Let's keep going. What about May to July? May, June, July. Now remember, I got 2023 in this as well. But this whole region was a bit drier than average. Look at Indonesia, showing up very, very dry. How about, let's just keep going. What about June through September? This is like all of summer. We noticed that we started to see later on this kind of ring that set up with a lot of thunderstorms here and higher pressure and hotter conditions, mainly around Texas, Louisiana, Arkansas. And the flow came around this, big storms. But Indonesia is showing up very, very dry, and the Indian monsoon not producing. So there's a few global stories here that we need to pay very close attention to as we watch these analog years move forward. Now, we'll continue to measure their effectiveness, and this is right now we're just combining years that had similar traits together to see what happened. And that's what I've got for you today. So we'll just watch this all week. Matt will talk to you tomorrow morning. Until then, have a good one. Thanks.